أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم Assalamu alaikum wa rahmatullah. Welcome back to the channel today. Today we will solve problem 5 uh, from projectile motion. And this problem, you see that we don't need those equations that we derived, the equation for range, time of flight, time taken to reach the maximum height, and the maximum height itself. Okay, although the word projectile is mentioned, but not every problem requires you to use those equations. Sometimes we have to resort to equations for motion under gravity. V equals u plus or minus gt, and equations like that. This is one of them. Before you start any calculation, make sure you draw a diagram to translate the problem. The problem should be translated into a diagram so that you can get a clear picture of the situation, the scenario, before you now start any calculation. So we are going to do just that. Solution. Okay, solution. How do we start? Look, let's read the problem. It says a projectile is fired, okay, horizontally with a speed of 30 meters per second. Remember, for a projectile, you have horizontal speed, you also have vertical speed because it's two-dimensional motion. Since they said it is fired horizontally, it means this speed is a horizontal speed and not a vertical one. This is your u sub x and is not u sub y. From the top of a cliff, and the cliff is 80 meters high. Okay, the first question says, how long will it take to strike the level ground at the base of the cliff? How long will it take? So you see here we don't use the equation for the time of flight. We do not use that. The equation for the time of flight, time of flight says t is equal to 2u sine theta divided by g. So your x is horizontal like this, and then from the top of a cliff you were told that it is projected horizontally. So you clearly the angle between them is theta is equal to 0 degrees. Okay, and if you put theta as 0 here, sine it will be sine 0, and sine 0 degrees is 0, which means 2u times 0, and you have 0 divided by g, and it means that the time taken is 0. How can it take 0 time, meaning no time, to cover this 80 meters high and come down? It doesn't make sense, and this is why we do not use this formula at all. We have to go back to the formulae for motion under gravity. Now, but we have to draw a diagram to illustrate the situation. We are told that a projectile is fired from the top of a cliff, so we draw a vertical line to represent the cliff, or if you like, you can do something like that, okay, to make it look nice. Let's say this is the cliff, and this cliff, how high is the cliff? The problem says it is 80 meters high. So it means from here you draw like this. This means the cliff is 80 meters high, and from the top of the cliff here, the projectile, which is an object under the influence of gravity, is projected in this direction with initial velocity u sub x, and u sub x is 30 meters per second. Remember, you have u sub y here, which is vertical velocity, and because it is at rest, your u sub y is 0. Let's say this is the ground level. Okay, this is the ground level. Now we know that because of the influence of gravity, gravity will not allow the projectile to move along this path, straight path like this. It will continue to bend, and you have the trajectory like this until it reaches the ground here. Okay, and we know clearly it has to take time. This is its trajectory. Now at this point, let us not forget that this horizontal velocity of a projectile is constant at all points. U sub x is 30 meters per second, and even when it reaches here, its U sub x is again 30 meters per second, which we will call V sub x, which is final horizontal velocity. It is still 30 meters per second, but then this U sub y, when it leaves here, the direction of U sub y is downward. U sub y is downward here, U sub y, and at this point you have the maximum U sub y because it will be increasing. So this is V sub y, which is the final V sub y, and you can get the resultant of the two velocities here. Okay, you can get the resultant of the two velocities drawn like this. This is the resultant of the two velocities, and we can call it just V, and this resultant makes angle theta with the horizontal. Okay, coming back to our question says we should get, it says how long will it take? It has to do with time. So here we will now use this equation to find the time taken. You use this equation. Remember this equation, S is equal to V sub I t. Since it is falling down, our G is positive, so plus half GT squared. Now I have different initial velocities. I have initial vertical and initial horizontal. If this S I am considering horizontal velocity, then my V initial should be V sub x. But I don't know the range. I don't know the distance from here to here. In fact, it is one of my target variable. I was asked to get that. So what I know is this one. This one is vertical, so I will use initial vertical velocity. So it means this one should be y, vertical displacement, and this one should be my u sub y t plus half gt squared. So now this should be this now should be 80 meters is equal to my u sub y is 0 times time t plus half um, multiplied by 9.8. Okay, we are taking 9.8 as our G, and then our T should be squared. Okay, this T is the time taken to reach here, because why do we say T is the time taken to reach here? Because when it is falling, it is covering vertical distance. Can you see this one is increasing? When it is here, it has completed the whole 80 meters that we use here. So if we use 80 meters, it means the time here should be the time corresponding to the time taken to cover these 80 meters. So here we have 80 is equal to, this one vanishes, 0 times t is 0. Then you have half, if you like, you can just say 2 into this 9.8. Just press 9.8 divided by 2, and your answer will be 4.9. So here you write 4.9 t squared. Then you divide both sides by 4.9. Divide this side by 4.9. 4.9 cancel 4.9, and then it means your t squared on this side, t squared remains is equal to, on the other side you have 80 divided by 4.9. Okay, so now divide 80 by 4.9. 80 divided by 4.9, this will give you 16.33 approximately, 16.33. But this t is squared. You have to take the square root of both sides, and therefore your t is equal to square root of 16.33, and square root of 16.33, square root 16.33 will give you 4.04. This is equal to 4. Correct to one decimal place, it will just be 4.0 in seconds. So the time taken is approximately 4.0 seconds. Next, we are asked to let's read the problem. B says, how far from the foot of the cliff? This is the foot of the cliff. This is the foot of the cliff. So how far from the foot of the cliff will it strike? So it strikes here. How far is this place from here? Okay, how far is the striking point is from the foot of the cliff. So this one we now get this. This is our R. Clearly this is our range. Again, we are not going to use the formula for calculating range that says R equals U square plus sine 2 theta over G. We just remember that remember when we were deriving that formula, we say that any horizontal distance is given by x is equal to x is the horizontal distance, is given by x is equal to u sub x multiplied by t, and that the highest x you can get is the range. And when that happens, this t is the time of flight. So if we want to get our r, it means r should be our r, okay, is equal to u sub x multiplied by the t, okay, the time of flight, and this time of flight is the one we calculated here, 4.0 seconds. So this one is pretty simple. We will just say okay, x is equal to u sub let me write b here. So we say x is equal to u sub x t, and then our x becomes range, and this is u sub x t. So this is equal to our u sub x is the horizontal velocity. You see that u sub x is 30 meters per second. So now we can use our 30 meters per second, then multiplied by the time is the time we calculated in A, and we got 4.0 seconds. So this is 4.0 in seconds. Per second cancel second, then we can now say 30 times 4.0, and this will give us 120. So the range, which is the maximum horizontal distance covered, is 120 meters. Okay, so this means the striking point is 120 meters away from the foot of the cliff. Finally, they said, with what velocity, look at it, with what velocity will it strike? We know that at the striking point, we have the horizontal, the final horizontal velocity v sub x. We also have the final vertical velocity v sub y. We have all of these. So which one are they talking about? The one they want you to get is this v, the resultant of these two, and we cannot get the resultant of these two unless we know both of them. Then we can use them to get the resultant. But as it is now, we only know v sub x, but we don't know v sub y. So we have to calculate v sub y, and remember v sub y is a vertical velocity. So what formula do we use to get our v sub y? Okay, to get your v sub y, a final velocity, you have a choice here. If you like, you can use this formula that says v sub y equals u sub y plus gt, or you can use the other one that says v sub y squared equals u sub y squared plus 2gy. I didn't put h here. The y here means the vertical distance here, this height. Okay, since your initial velocity is vertical, your final velocity is vertical, your initial velocity must also be vertical, and the distance here must also be vertical. If you are using vertical, everything should be vertical. If you are using horizontal, everything should be horizontal. We are emphasizing on this because once you make a mistake and combine both vertical parameters and horizontal parameters in a single equation, you are not going to get a good result. So let's begin. The second formula will give more accurate result compared to the first formula because we approximated our t here correct to 1 decimal place. The second one will give more accurate result, but the difference is not much. So you have a choice. If you like, you can use this one. If you like, you can use this one. So this is C. Okay, if we use the first one, our V sub y is equal to VU sub y plus GT. Then our V sub y is equal to U sub y is 0, is initial vertical velocity. Look at it, 0 here. So we can put 0 here plus, and this G is 9.8 times our T. Our T, we approximated it to 4.0. So this will give you you just press 9.8 multiplied by 4.0 and you have 39.2 in meters per second. You see, if you approximated this T to 4.04, which is 2 decimal places, if you multiply 9.8 by 4.04, you have 39.6, approximately 39.6. There is a difference of 0.4, but since we approximated it to 1 decimal place, we are going to keep it that way. The other one, if you use this formula, you will get 39.6, but we are maintaining the first one, inshallah. Okay, now we know the initial, the final vertical velocity. So we know that this one, its value is 39.2 approximately. This is 39.2 in meters per second. Okay, 39.2 in meters per second. Now we can get this resultant velocity that we are asked to find. You see, we can use Pythagoras theorem, because this one you can bring it here, and when you bring it here, you see you have a right angle here, angle 90 degree, and this becomes hypotenuse. So the square on this one is equal to the square on this plus the square on this, according to Pythagoras theorem. So now we can say our V squared, which is the resultant, is equal to V sub x squared plus V sub y squared. If we take the square root of both sides, our V becomes square root of V sub x squared plus V sub y squared. And this is equal to square root of our V sub x is 30 squared plus our V sub y is 39.2 squared. Okay, so this is equal to you now take your calculator. If you want to press this one, just take your calculator, press this square root, then you open a bracket. If you open a bracket, you can now press 30 squared plus 39.2 squared, then you close the bracket. Look at it here. Okay, the root is there, is hidden. Then square root, open bracket, press 30 squared plus 39.2 squared, close the bracket. After that, press the equality sign. If you press the equality sign, look at your result. 49.36, correct to 1 decimal place should be 49.4. So we have 49.4 in meters per second. This is the final velocity, but because velocity is a vector, it has magnitude and direction. So this one is the magnitude of the velocity, and we have to find the direction. The direction of the velocity is this angle that you see here. The velocity, the direction of the velocity is this theta that you see here. So um, how do we find theta? If you look at this one, this side is the opposite, okay, and we know the opposite side are equal, so this is our v sub y, and this is the hypotenuse, and this one is the adjacent. Opposite over adjacent is a measure of tangent, so we can say tan theta equals opposite over adjacent, which is v sub y divided by v sub x. So we can now proceed and say tan theta equals v sub y divided by v sub x. Our v sub y was 39.2 in meters per second divided by our v sub x 30.0 also in meters per second. So meters per second cancels meter per second, and then our theta is tan inverse of 39.2 divided by 30.0. So this is what you will do. You now press shift before you press the tan. Shift, tan, and you see tan inverse appears. Then you now open bracket and say 39.2 divided by 30.0. Then you close bracket. After closing the bracket, now you can press the equality sign, and your angle, correct to the nearest angle, your angle is 53 degrees. You see, correct to the nearest angle. When we approximate it to the nearest whole number, we get 53 degrees. So it means the final velocity, okay, the velocity with which it strikes the ground is, that velocity is 49.4 in meters per second. Is it above or below? Then you have to specify and say 55 degrees below. Clearly it is below, right? So you say 55 degree below what? This is the x-axis and is plus x-axis, so below plus x axis. If it is above, you say above, but this one is below plus x-axis. So with this one, we have successfully solved problem 5. Now we move on to problem 6. Okay, problem 6 says that a baseball is thrown with an initial velocity of 10 meters per second at an angle of 30 degrees. So this one is the ordinary one, the one that has a general form. So you have the y plane here, and then you have the x here. It is projected in this direction with an initial velocity u 100 meters per second, and the angle it makes here is 30 degrees with the x-axis. So the trajectory is like this. Great. And we know that we have u sub y here. We also have u sub x here. Okay, now how far from the throwing point? How far from the throwing point? Where is the throwing point? This is the throwing point. How far from the throwing point will the baseball attain its original level? How far? So how far has to do with distance. So they want to know the distance of the baseball from the throwing point. At the end of the day, where is the original level? This is the original level. So if it strikes here, it has come back to the original level. Can you see? So how far it is? Okay, from the throwing point, will the baseball attain its original level? So it means they want us to get this range. The distance from here to here is what we are required to find. They want us to get the range. So what will be our range? Now we see that the formula is very ordinary. Okay, r is equal to u square sine 2 theta divided by g. This will give us the range, and this is equal to our u is 100, so we say 100 squared sine 2 into theta, and our theta is 30 degrees, divided by our g 9.8. Okay, we now press our calculator, but before that, know that this means 2 times 30 degrees, and this will give you 60 degrees. So this is equivalent to sine 60 degrees. Let me write that: 100 squared, then multiplied by sine 60 degrees divided by 9.8, and this is equal to, so we can now press 100 squared multiplied by 100 multiplied by sine 60 degrees, then divided by 9.8. Okay, press equality sign and you will get 883.7 in meters approximately. This is what you will get: 883.7 in meters. Now we can move on to problem 7, which is the last one we will consider under projectile motion. Problem 7 says a ball is thrown from the top of one building toward a tall building 50 meters away. The initial velocity of the ball is 20 meters per second, meaning the ball was projected with this velocity, and it is projected at an angle of 40 degrees above the horizontal, meaning above plus x-axis. How far above or below its original level will the ball strike the opposite wall? And we are asked to take g as 9.8 meters per second. So here is the thing: you have a wall. This is a wall here. Okay, you have a wall here. Then you have another wall, and this wall is a bit taller than what you have initially. Okay, we have two walls here. Then the two walls are 50 meters apart, 50 meters away from each other. You see, they are 50 meters away from each other. Now you have an object here. Okay, you have an object here. This object is thrown with an initial velocity u is equal to 20 meters per second, as given here, 20 meters per second. Okay, but because we know due to influence of gravity this object will not follow this path, it will bend. And there are two possibilities. This object can either go like this, and at the end, or let me say about three possibilities. Of course, it can go like this and hit here without touching here. So when that happens, you will have a vertical distance here. You will have a vertical distance here, y. Let me call that y1. The second possibility is that it can go up like this and then come down and hit here. In this case, it is now in the same level, the same as the initial level from which it was projected, so your y is 0. Or when it reaches here, it can bend downward and hit here. Now you have another y, which we are going to call y2. So the question is, you see what they say, how far above or below its original level? The original level is this one. So if you calculate the vertical distance and you find out that the vertical distance is positive, let's say you get 40 meters, and we know 40 meters is positive, so it means it strikes somewhere here 40 meters above the horizontal level. But if you got the displacement as minus 40 meters, it means it strikes somewhere here 40 meters below. This is below and this is above, and you will differentiate only when you have a sign. You take upward positive and downward negative. Okay, so we don't know which one, but if we have zero, then we know that it is on the original level. It strike here, so your y is 0. But I think because they know that we will not have that 0, and this is why they say how far above or below. Okay, if we have positive value for y, it is above. If we have negative value for y, it is below the original level. Okay, having said that, let us now remember the equation that I said you can use to get vertical displacement of a projectile at any given time. That equation is y is equal to u sub y t minus half gt squared. This is the formula you need. Okay, this is the formula you need. But clearly, before I use this formula, I need to know the time. I need to know the time it takes before I can get this y. Okay, because y is the decisive factor. So how do I get my t? I will now come back to this this range, because if it has reached here, whether it strike here or it strike here or it strike here, the horizontal distance, the range is still 50 meters as given. Whether it strike here, you see the distance remain 50. If it strike here, it remain 50. If it strike here, it's still 50. So we now use the formula for range, and not that r equals u square sine 2 theta over g, because it has no t in it. This one, r is equal to u square sine 2 theta over g. It has no t, so there is no point in using this one. The one I will use is the initial one that says x is equal to u sub x t. And when x is maximum, it becomes the range, which is equal to u sub x t. So from here, I can say my t is equal to r over u sub x. I will divide both sides by u sub x, divide both sides by u sub x, u sub x cancel u sub x, so my t is r over u sub x, and my r is this 50, so this is 50 divided by u sub x. So what is my u sub x? So I go back to this equation and get my this diagram. I know that I have here u sub y, and I have here u sub x, and my u sub x is this u, the angle it makes with the horizontal 40 degrees, so I have 40 degrees here, u cos 40 degrees, this is 20 cos 40 degrees, and then 20 cos 40 degrees is what? I can simply place it here, 20 cos 40 degrees, so I can get it directly. So I press 50 divided by 20 cos 40 degrees, and then this will give me 3.26 approximately. So this is 3.26 in second. This is the time it takes. So this time I have to take this time. I need this time here. The next thing I need is this u sub y, and from the diagram here, my u sub y is u sine theta, and this is my u is 20 sine the angle I am given 40 degrees. So I press now 20 sine 40 degrees. This will give me 12.86 approximately, 12.86 in meters per second. Now this 12.86, I will bring it here for my u. So my y becomes open bracket. What is my u? U sub y, 12.86. And what is my t? My t is 3.26 close bracket minus half into what is my g? My g is 9.8. Then open bracket again, my t is again 3.26, but t has to be squared, so I will now square it. So this is equal to, from here directly I will just press open bracket 12.86 close bracket, then I open bracket again 3.26 close bracket, then minus this half is 0.5, so I will press 0.5 open bracket 9.8 close bracket, then I open bracket again 3.26 close bracket, then I press square. Now I will press the equality sign, and this will my value will be the decisive factor. Now look at the value I got. I got minus 10.2 approximately, minus 10.2 meters approximately. So what does it tell you? Remember what we said. If it is positive, it hit above the level. If it is negative, it hit below the level. So negative sign means that it hit below the level, and this is our correct path. The last one here is our correct part. It means it hit 10. I'm writing 12 here, 10.2. So I have 10 from this level to this level is 10.2 meters. Okay, this is the meaning. So we conclude that we say that the ball hit the opposite wall 10.2 meters below, not above, below its original level. That's our conclusion, and this is the last problem we are solving on projectile motion. I hope it's clear to all of you. Assalamu alaikum wa rahmatullah.